Greetings and welcome to Rudin's bullshit of unreal analysis. This is part 4. So let's carry on where we left off. So if you recall correctly, we finished off over here. Okay, let's go right back here. Yeah, just before the distributive property. So this first of all is not a law. It's a property that's explained using areas, which, by the way, are or were understood as plain numbers by Euclid and the ancient Greeks. So the product of two arithmetic means. And there's nothing special about that law. It's not a law. It's not special about that property. It's very easy to understand when using the geometry. And this statement here that it holds for all x, y, z is an element of f is rubbish because f must be a field of numbers. Okay, so it doesn't hold for anything else but numbers. Now, it's really just a property of arithmetic, and it cannot be applied to any other type of element. So writing, for example, is an element of f makes no difference whatsoever. I mean, this part here holds for all. It's just garbage. He's just trying to basically enforce set theory onto doing the primary coating of set theory before the final thick coating of bullshit takes place much later in the document. So the next thing he says in 1.13, one usually writes again in any field. He's trying to be generic, but he's not generic. He's just bullshitting. I mean, in all these operations, look here, x minus y, x over y, Rudin makes claims that he hasn't proved. Rudin didn't understand the concept of number, much less the concept of arithmetic. Okay, so he had no idea what a number is, just like most of you don't. Yes, you have a superficial notion, but you don't know where it came from. Okay, in fact, most of you even learned how to count with integers or measure with integers or natural numbers, but you didn't understand what they meant. So before I continue, I'd like to recommend this article. It's actually written for toddlers who already know how to count, but it shows you how you can teach your toddler, okay, to do every arithmetical operation on any fraction, okay? And it also deals with negative numbers or so-called negative numbers, right? So I'll put a link to this and you can look at it and you'll see that nothing that Rudin actually tells you in here has any specific exotic value. It's just BS. It's just a lot of verbal diarrhea, in my opinion. Okay, he's not really explaining anything. So, but I do explain things in my article, Unlocking the Mystery of Numbers. So, now, then he says statement A above here is a cancellation law. Again, here we go with laws and authority. Laws, authority, decrees. Look, these so-called actions are not actions. They're basically a rehashing of Euclid's common notions. These are Euclid's common notions, okay? The first one says, things equal to the same thing or equal to each other. And if equal things are added to equal things, then the wholes are equal. that's A. If equal thing, x, is added to equal things, then the whole is equal, right? And things coinciding with one another are equal to one another, and the whole is greater than the part. Okay, and so he also gives these so-called axioms, as he stated here, minus x. But as I showed you in my article, this is what a negative number means. Okay, and I explain it in this article. Again, I'll place a link to this article so you can go over it, because a lot of you didn't do your homework. You were supposed to study this article. So this time, before you post your 2 cents drivel, at least take the trouble of studying the article, okay? So statement A this year is common sense. It's not a law. It's not even a property, really. Common notions 2 and 3. These two notions that you see in here. These two. Okay? Then, let's continue. In 1.14, which is everything that came before this point, it seems like he forgot to say X and Y and Z are elements of Q. And charlatan that he was, his book's inconsistency is evident throughout. Okay. Now, the axioms for multiplication imply the following statements. I wonder how the crank would justify C without numbers and with 0 being accepted as a number. So, yes, he does say 0 is, X is not equal to 0, but this means that 0 cannot be a number because the so-called axioms for multiplication imply these statements, but they don't work for 0, okay? Isn't that remarkable? And then he says this proof is so similar to that of proposition 1.414 that we omitted. Garbage. The field axioms imply the following statements, again, now he says, for any element of F. And although Rudin doesn't mention that 0 and 1 are identity elements, these two paragraphs are dedicated to 0 and 1 and are priming for later stating that these are the identity elements. He was such a fraud. And when I saw proofs C and D many decades ago, they seemed quite clever to me. They seemed like quite clever tricks to prove that a negative times a positive is a negative and a negative times a negative is a positive. But they're actually smoke and mirrors because the fact that plus X and minus X are 0 is the foundation of these proofs. And so if I have X and I remove X, I'm going to have 0, okay? And if I don't have X and I want to remove the need for X, I'll still have 0. So it goes both ways. And one can just say 0 is equal to AX plus minus A in brackets times X because you don't know yet what this means. And then again, you use either the distributive law or the additive inverse to prove the statement that follows, okay? So yeah, I thought that was a little trick, but really turned out to be insignificant crap. So, and then we've got a proof that 0x plus 0x is equal to 0x. It's absolutely amazing, isn't it? Absolutely fun. I mean, it's fundamental knowledge, which, and I'm saying this sarcastically, which even a 2-year-old would laugh at. So next, he goes to a lot of effort to show that the product of any two non-zero numbers cannot be 0. But it's not like he has anything of value to say. And here in both C and D, which are easily deducible without all the fuss Rudin makes, you can see these things explained in my article. Okay, this article that I shared with you a couple of videos back or one video back. So I would recommend studying that carefully. Excuse me. Then an ordered field is a field F, which is an order. So here we go again. Now we've learned what a field F is, with two definitions on it. Field early on. How was it defined? Can any of you remember? Let's see. It's a set with two operations called addition and multiplication, but nothing about addition and multiplication, by the way. None of these things that this idiot has done here have anything to do with the actual operations, arithmetic operations of addition and multiplication. But now we can have an ordered field. And the difference is that these extra constraints are required. And of course, these, again, do not apply just to any element as Rudin tries to, pull the wool over your eyes, saying that it's set theoretical and that we need set theory. It applies to numbers. Okay. So that's pretty much it. And then he goes down finally. Oh, there's one false statement here. He says the following statements are true in every ordered field. They're not. They're only true for numbers. And then he says, page 17, he hasn't defined number, he hasn't defined arithmetic, he hasn't explained anything of value. And now the real field, which you see down here, right here, the real field, he hasn't said anything about real fields without any definition of number, never mind R. So that doesn't stop him from producing bullshit theorems and definitions. So we're about to leave the definition phase in the real field, and on 1.19, which is already 17 pages later, we're about to be introduced to real fields without even knowing what a real number is, by the way. Guess what? It only comes down here. It says the members of R are called real numbers. So it says they exist in ordered field R, which has the least upper bound property. Moreover, R contains Q. And there's a proof of this, which is also a lot of smoke and mirrors, gas, right in the appendix of this chapter. And so it says the proof actually constructs R from Q. It does no such thing. In fact, he hasn't even explained Q. Nobody even knows what a rational number is. Okay? And so we get to do a few theorems before we get to that stage, and then finally we get to the proof of 1.19. So what I'm trying to tell you, people, is that real analysis is not mathematics, it's mythmatics. Okay, not required. And thank the gods that my ancient ancestors had the brains to not fall into this trap. It's a trap started by George Cantor, okay, that delusional moron who was in fact a nutcase, just like all his followers, just like most of you are today. So what I'm telling you right now is meant to wake you up, to point you on the right path. None of this is mathematics. Absolutely none of it. And it's almost stressful going through it because it's all so wrong. In every possible aspect, it's wrong. It's ill-formed concepts built upon more ill-formed concepts, built upon smoke and mirrors, some more ill-formed concepts, some more bullshit, etc., etc. It's a big pile of trash, and yet it's a course that is required in a math degree. So you have to pass real analysis, otherwise you don't get your math degree. Now, and by the way, this isn't the Archimedean property that he stated here, but I'll get back to that in the next video. If you're not already a subscriber, become a subscriber to my channel. This is my channel. And become a members only follower for just $4.99 a month to learn a lot more than what I'm sharing with you here. And also follow me on academia.edu. This is the academia site. Okay, just click on this icon and it will show you and there's also a link in the detail section. I'm John Gabriel. Till next time.